Alright, I hope this video finds you all well and enjoying your homeschooling. This video is on binomial expansion. This particular topic I've seen on almost every IB exam I've looked at, so it's a very important one, and it does have something to do with our Pascal's triangle that you did a little bit of work with hopefully before you watch this. So we will kind of cruise through this and take a look. The triangle that you have looked at, and I'm going to just adjust this screen. So we're back. Hopefully you did a little bit with Pascal's triangle. It does, that the blue numbers are Pascal's triangle, and the pattern is that you add what's above it to go below it. So like 0 and 1 make 1, 0 and 1 make 1, 0 and 1 make 1, 1 and 1 make 2, etc. And it goes down, but it's going to be very helpful for us. We do need to, this is the binomial expansion piece. So a binomial is just two terms. So any two terms, any x and y, I can use these blue numbers as the coefficients as I expand the binomial. So instead of, for example, coming down here to the fifth power, doing x plus 5 times x plus 5 times, like foiling them, and then doing double and triple distributive property and combining like terms to get this mess. This is a shortcut procedure because the expansion has this unique characteristic of Pascal's triangle being the coefficients and a couple other properties. We can use it quickly to expand any binomial. The important thing to remember is this first row is a 0 row because anything to the 0 power is 1. This is the first row, and the first power just means this becomes 1x plus 1y. This is a basic quadratic. If I were to square this, you always get double what the x and y values are. And then we get into territory that we haven't seen as much, but we will. A couple things to keep in mind as we look at expanding a plus b to the n, a and b being anything, n being any power, but the n is going to represent what this power is here, and notice that whatever n is, we can look to that row of the triangle to get our blue coefficients. A couple things to notice as we go from left to right. That means going this direction here, that these powers right here of a, things that in the front, all decrease by 1. So it starts at the highest power, whatever the beginning power is, then it's 4, then it's 3, then it's 2, then it's 1, and then it doesn't exist. And powers of b increase by 1, so there is no y, b is y in this case, there is no y, then it's 1, y second, y3, y4, y5. So they go opposite order. A couple other things to keep in mind to remember, the powers of a and b. So in this case, these x's and y's, those always add up to whatever the binomial exponent is. So 4 and 1 make 5, 3 and 2 add up to 5, 2 and 3 add up to 5, 4 and 1 add up to 5. So that's always going to be the case, so you always will be able to track your powers. And the number of terms is always one more than the exponent. So there are actually 6 terms here, even though that's an expansion of 5. This is an expansion of 4. There are 5 terms. So those are important things to keep in mind. So you might want to jot those down as we go forward. If you need to pause it to write those down, that's okay. Do so. We are also going to, I already told you this, that the coefficients, the numbers in front, are the numbers in Pascal's triangle, and the row number of the triangle and the power of n in your expansion match. So now we're going to just play around with these a little bit. So if I want to expand this guy, and again, I've sort of, this is a 1, 3, 3, 1. Those are the coefficients from Pascal's triangle, and this is a cubic, so I already know those coefficients are in play. What I have to be aware of as I look at this is that I've kind of messed with you a little bit because this whole thing is now your a. So 2 and x together make a, and 3 is your b. And I'm going to use blue to represent like what the coefficients are that are there. The 1, that's a 1 by the way. The 1s and the 3s are there no matter what a and b are. So they're always in there. Those are your coefficients. The red and the green are going to give me my values by power. So I'm going to start and do this all in color. So I'm going to expand this. Coefficient is blue. It's always a 1 if it's cubic. then I have to go to my red term, which is 2x. And remember, that a value to begin with is going to pick up this cube. And that's all the powers that are available. So I don't even need to write the green thing at all. Then I'm going to go plus, because I had a plus here. Now I'm going to go to blue because the coefficient from the triangle is 3. Then I have to take my a value, and its powers are going to drop by 1, so it's going to become 2x squared. But now I do have this 3 showing up because its powers are going up by 1, so it's going to be 3 to the first. Notice those add up to 3. Then I'm going to come down here, put in my coefficient 3, always a 3 in the third term. Then I have to take the a value. Powers are going to go down by 1. So it was 3, 2. Now it's to the first power. And as they go, these powers go down, the b value powers, again, 3 is in place of b. And that means it's right here now is where we are. That 3 is going to be squared. And as I continue this, again, blue for my coefficient, which is 1. I usually wouldn't write those, but I'm doing it so you can kind of see where they come from. This term is gone now. See, in the very end over here, there is no a. So I don't even need to write 2x to the 0, because that's just 1. But I do need to write 3, and it now picks up all of the powers. So again, the blue numbers come from Pascal's triangles, coefficients. 2x is my a value, so it gets cubed first. Then it drops to a square, then it drops to a first power, and then it doesn't exist at the end. This term at the back, b, starts off not existing. It gets a power, so it's a first power. Then it gets this another power, and all the way up to 3. And again, notice all the powers in each term add up to 3. Now I can actually simplify this thing. And this is where you got to be careful, because this is what messes everybody up. This 2x is being cubed, so I got to cube the 2 and the x. So this term becomes 8x cubed. This 2 is squared, so it becomes 4. 4 times 3 is 12. 12 times 3 is 36. So this one becomes 36x squared. So make sure you're okay where I'm getting these numbers here. Plus, this 3 is squared. 9 times 2 is 18. 18 times 3, I believe, is 54. And over here, I have nothing but the 3 cubed. And 3 cubed is 27. And that is the expansion of this thing right here. There you go. Pretty crazy, right? All right, guess what happens next? You get to pause the video, try one yourself, x minus 5 cubed, pause video, try, okay. Hope it went well. This is what you should have gotten right there in blue. Again, feel free to pause, take a look, see where they all came from. This is kind of an important topic because it shows up on the test. And it's also kind of fun. All right, we're going to do the same thing, but we're going to expand this to the 5th. So the first thing I'm going to do is if I went to the 5th row of Pascal's triangle, I'm kind of looking at one now. So it would be 1, 5, 10, 10, 5, 1. You should all have a triangle in front of you, or if you flip back, you can see where they are. So, and now I'm going to, this is my A here, and this is B, and I'm taking that negative with it, so we got to deal with that. So the first thing is going to be 1, and I have to take this A value, and the A value is going to get all of the power, so it gets A to the 5th. This thing gets nothing. Too bad for you. Then I'm going to come over here, and I write my coefficient of 5. I'm getting that right from here. X is now going to get a 4th power. And the B value, which is negative 2 over x, gets 1. Again, these have to add up to 5 every time I go. I continue with, oops, that's going to be a 10 now. I'm moving right to here. And the A value is x. And again, this was a 5, 4, now it's a 3. And my negative 2 over x, which really is making this thing a little bit messy for me, it goes from a 1 to a 2, and I can track these two have to add up to 5, and they do, so I feel pretty good about that. Now I still have another 10 over here. Again, I'm just moving down my row in my 5th row in the triangle. X loses another power again, so he's down to 2, and negative 2 over x picks up another power. Negative 2 over x picks up to a 3rd, and I keep going, plus 5, My x value is now just down to x. I'm going to lose parentheses and I'm not going to write the 1 anymore. And my negative 2 over x is picking up powers like crazy. It's gone from 3 to 4. Again, they add up to 5. And then my last lead coefficient is a 1. X's are no longer there. And just my b value over here is going to get negative 2x. He gets all of the exponents now. And then my job is to just clean this up, which isn't as fun as you'd think because I have this rational expression, but it's not a big deal. So I have a 5 and a negative 2 to the first, so that's going to give me minus 10, x to the fourth, and then x on the bottom. So this is going to cancel, and it's going to leave me x cubed. So again, x to the fourth divided by x cancels to x cubed. Over here, I have negative 2 squared is 4 times 10 is 40. And I have x cubed, and this x squared is going to be on the bottom. So this really is like having x cubed over x squared, which cancels to just an x. So that's going to happen as we move through this. Negative 2 cubed is negative 8 times 10 makes this minus 80. And now notice that I have more x's in the bottom. So this piece would give me x squared on top, and this would give me x cubed, and that is over x. So notice how things are kind of following a slightly different pattern. Negative 2 to the fourth is 16, and 16 times 5 is 80, so I'm going to have plus 80. And this x is on the top. Now I have 4 of them on the bottom, so this is going to be over x cubed. And this is just going to become minus 2 to the fifth. 2 to the fifth is 32. And all my x's are on the bottom. There we go. And this is what my answer is. Expanding this guy up here. All right, you get one to try. Pause the video, try it. Notice you have a negative 1/3. That negative goes with it, and your 3x. This 3 is going to hit each of the powers as well. Pause, try. Here you go. Unpaused. There's what you should have gotten. Again, there you go. All right, moving on. I'm only allotted 15 minutes per video, and I'm almost done with that, so I'm just going to stop this video, and we're going to have a second video to go through example 3 and 4 as we expand this. So there you go. That's all I got to say for now. I'll see you in a few minutes when you look at the second video.